Think about any team project you've ever been on. There's always that one person who tries to do everything themselves, right? It almost never works out. The best teams, they have a great project manager, someone who knows exactly who's good at what, who to call on, and how to stitch it all together. Well, believe it or not, the world of AI is wrestling with that exact same problem.
Right? I mean, if you've got a complex problem that touches on, say, law, finance, and technology, you don't just go to one person. You bring in a team of specialists. So the billion-dollar question is, how do we get all these different AI models, each with their own unique talents, to work together like that? Well, that's the problem a fascinating new system called Router-R1 is built to solve.
Okay, so here's how we're going to break this down. First, we'll talk about why the current way of doing things is hitting a ceiling. Then, we'll meet our new AI coordinator, Router-R1. We'll peek under the hood to see how it learns, see how it stacks up against the competition, and then wrap up with the 3 big reasons why this is such a big deal. Let's dive in.
So before we can really appreciate what Router-R1 does, we got to understand the status quo, and, more importantly, where it's falling short. And it all boils down to this idea called single-round routing.
And the key word here is single. You ask a question, an AI router plays matchmaker and picks what it thinks is the one single best model for that job. Then that model gives you a single, one-shot answer. That's it. End of story.
And that's the real problem, isn't it? This straight-line process. It's kind of like asking a brilliant historian to solve a multi-step calculus problem. They might give it their best shot, but they just don't have all the right tools. For those really tricky questions that need several steps of reasoning, this one-and-done approach just doesn't cut it. It hits a wall hard. And so, this brings us to Router-R1. Now, instead of thinking of it as a simple matchmaker, think of it more like a super-intelligent project manager. It doesn't just delegate the task and walk away. It actively manages the entire process, start to finish.
This really lays it all out, doesn't it? On the left, you've got the old way, static, one-shot, linear. But on the right, you've got Router-R1's method. It's dynamic, it uses multiple models, and most importantly, it's an adaptive loop, not a straight line. So how does this loop actually work? It's surprisingly elegant.
It all starts with a think step. The router, which is a smart AI itself, looks at the overall problem and asks, okay, what's the very first piece of the puzzle I need to solve this whole thing? It's like its own internal strategy session. Then, once it has a plan, it acts. It routes that smaller, specific question to the best specialist it has on its team. If it needs a hard fact, it might call on one model. If it needs some creative analysis, it'll call on a completely different one. And finally, it takes the answer it gets back, adds it to what it already knows, and then it repeats the cycle. It thinks again, all right, now that I have this new info, what's my next best move? And it just keeps going. Think, rote, repeat, building the final answer piece by piece, layer by layer, until the whole problem is cracked. So you might be wondering, how does an AI get so good at being a project manager? Well, this is the secret sauce. It's a training technique called reinforcement learning. Now that might sound complicated, but the idea behind it is something we all understand. It learns from trial and error, getting rewards for doing things right. This feedback is based on 3 simple goals. First, and this is the big one, did it actually get the right answer in the end? That's the outcome reward. Second, did it follow all the rules and structure its answer correctly? That's the format reward. And third, and this is really important, did it get the job done efficiently without wasting a ton of money? That's the cost reward.
And what's so cool about this is that developers get a knob they can turn to control that balance between performance and cost. It's this little thing called alpha. If you turn alpha down, the router will go all out, sparing no expense to get the absolute best answer. But if you turn it up, it becomes more frugal, always looking for the cheapest way to get a good result. You get to decide on that trade-off.
Okay, so the theory is fantastic, right? An AI coordinator that can learn to be both smart and thrifty. But does it actually hold up in the real world? Let's check out the data.
This chart pretty much says it all. What we're looking at is the average performance across 7 different tough question answering tests. That first bar, that's the average of more than a dozen other methods, including some really powerful ones. And that second bar way over on the right, yep, that's Router-R1. It's not just a little bit better, it's a huge leap forward.
And hey, you don't have to take my word for it. The researchers who built it said it themselves. Router-R1 achieves SOTA performance. That stands for state-of-the-art. It's the new top dog. So we know it's incredibly smart, but is it efficient with its brain power?
This is where things get really clever. This shows how many times the router calls on its team of experts. And look, for simpler, general questions, it keeps the team small, making fewer calls. But for those really complex, multi-hop questions that require connecting a bunch of dots, it smartly calls in more help. It doesn't waste resources. It scales up only when the job actually gets harder.
All right, let's bring it all home and talk about the 3 superpowers that really make Router-R1 a potential game changer for the future of AI.
Superpower number 1. It's just plain smarter. By acting like the conductor of an orchestra full of specialist AIs, it can tackle problems with a level of complexity that would be totally impossible for any single model to solve on its own. This is the power of collaboration.
Second, it can be way, way cheaper. Just look at this table. You can set it to performance-focused mode, and yeah, it'll deliver the highest possible score, but it'll cost the most. Or you can switch it to cost-balanced mode, and the performance is still incredibly strong, but the cost just plummets. It gives you amazing performance, but on a budget you can control.
And finally, its third superpower is that it's unbelievably flexible. I mean, in the world of AI, new models pop up constantly. Router-R1 can take a brand new AI it's never ever seen before, and without any expensive retraining, it can just read its description, kind of like a resume, and immediately figure out how to best use it on the team. That's a huge advantage.
So what's the bottom line here? First, Router-R1 shows us how to get AI models to stop working in isolation and start collaborating like a real team of experts. Second, it proves you can build systems that are both incredibly powerful and smart about how they spend money. And maybe most importantly, this whole approach feels like a blueprint for a new generation of AI systems, ones that are way more powerful, adaptive, and capable than anything we have today.
And that leaves us with a really exciting question to think about. We are right at the beginning of this new era of AI collaboration. As this kind of technology gets better and better, and AIs learn to work together as seamlessly as any team of human experts, what are the problems that seem impossible today that they might finally be able to solve for us? It really makes you wonder what's just around the corner.